This video doesn't actually correspond with any direct chapters. It kind of combines information from chapter 24 and the effects we see on the information we learned in chapter 7, essentially. First, we have pole and line fishing. This is when fish are enticed by bait fish and are caught one by one on hook and line. Problems we face are localized depletions, and a solution would be to fish in different locations each time, or to keep fish of a certain size, generally larger sizes, to allow populations to replenish themselves. Dive fisheries and hand collection. Here we have divers that collect fish by hand. Again, we're going to see the same problems we saw with pole and line fishing. We'll have localized depletions, and we can fix this by fishing in different locations each time, as well as only keeping fish of a certain size to allow the populations to replenish themselves. Pots and traps. Baited traps trap lobster and crab. Problems: females with eggs and immature animals are caught. Traps that are lost become trash that kills. Traps drag on the bottom and destroy habitat, and marine mammals get tangled in lines. Solutions: make holes large enough for younger animals to escape. Dredging. Large metal cages with teeth are pulled behind a boat along the ocean floor to gather bottom-dwelling organisms. Problems: this is extremely destructive to bottom-dwelling habitats and is not selective for certain species. Solutions: create dredges that minimize turbidity and have potential exclusion devices. Purse seining. A net is cast out using a smaller boat, then the net is closed like a drawstring bag. Problems: dolphins, sharks, turtles, and immature fish are often caught. Solutions: nets can be loosened at the top to allow dolphins to escape. Long lining. Long lines, generally miles long, attached to about 40,000 hooks or more, are laid on the ocean floor and then reeled in. Problems: turtles and sharks are often caught as bycatch, and birds get entangled by the hooks. Solutions: streamers to scare birds and weights on hooks to make them sink faster to get past the turtles and sharks that could be surrounding the area. Trawling. This is when boats drag a net that scrapes along the bottom of the ocean. Problems: it destroys habitats on the ocean floor. We see bycatch, more is caught than allowed, and it drowns turtles. Solutions: we have turtle exclusion devices, also known as TEDs, that can be added to nets. Turtles can also be resuscitated. Next we have ghost fishing. Ghost fishing is a little bit different from the other techniques we have discussed. This one is unintentional. It occurs when organisms get trapped in abandoned fishing nets and cages. The problem: again, it's unintended fishing that occurs, and organisms generally die or drown as a result. Solutions: first is to create sturdier support structures for fishing, and then also netting systems that allow larger organisms to escape easily. This brings us to different aquaculture practices. These are less of the fishing aspect and more of the creating some kind of culture we can obtain all the organisms from. So the first type is going to be open aquaculture. We have two types. The first is a sea cage. This is going to be active feeding, where whoever owns the aquaculture itself is feeding the organisms. Here, organisms are housed in an enclosed cage in their natural habitat. The problem: we have increased disease and parasite transmission, pollution into the surrounding waters, and reduced water quality. Solutions would be regular water quality analysis and treatment, as well as preventative measures such as limiting chemical types and amounts that can be added to the enclosure. Our second type of open aquaculture is including sticks, ropes, racks, and cages. It's considered passive feeding because the environment itself is providing the food source for the organism. Here we're generally going to see shellfish, and in the larval stage they are attached to these sticks or racks and placed in a natural waterway. The problem: there's no added nutrients or food required, so there's little concern for pollution other than the removal of the sticks or racks themselves. Sometimes they can break and end up in the waterway, and that's pollution that we don't want to have. Solutions include checking the sticks and racks on a regular basis for repairs and making sure that you dispose of them appropriately. Our next type of aquaculture is semi-closed. This is when organisms are placed in an inland pond with piping to and from the oceans. Wastewater is pumped out and clean water is pumped in. Problem: the pollution by wastewater. We're essentially taking all of the deposits made by these organisms and sticking them into a waterway. This can lead to habitat destruction as well as a drop in natural waterway water quality. Solutions include filtering the wastewater before pumping it into the waterway. Our last type of aquaculture is a closed aquaculture system. Here, fish are farmed in an inland pond and fed. Problems: it's a continual reliance on wild fish stocks for fish meal. Solution would be to increase the amount of fish eating at a lower trophic level in these ponds and decrease the upper trophic level dwelling organisms. This brings us to sustainability measures, aka the reason we're talking about our fishing techniques in the first place. If you're trying to figure out which one is the most environmentally sound, we have two that are coming hand in hand together. First is the pole and line fishing. Second is going to be hand collection. These are the best harvesting methods because these techniques preserve the bottom habitat, allow for quick release of bycatch, and limit ensnare net from equipment loss, such as traps or nets. So before we talk about the effects on aquatic biodiversity, we need to know a little bit about the specifics of aquatic biodiversity. So first, why is there greater species diversity near oceans or lake shores? Well, shallow water allows for sunlight for autotrophs. Autotrophs provide the base of the food chain, and the shores provide spawning areas for juvenile nurseries. Second, why is there greater species diversity along the deep ocean floor where there is no sunlight? Well, we have deep sea vents that have autotrophic bacteria species that provide the base of a food chain to other organisms in these regions, and the seafloor also has an abundance of nutrients. Would or wouldn't we find greater species abundance and diversity at the bottom of a very deep, large lake? We're thinking about it in comparison to the ocean we just talked about with the second question. Well, like the bottom of the ocean, a large, deep lake will have the nutrients and decomposed matter, and so species abundance and diversity will be higher than in the mid-zones. However, lakes do not have deep sea vents, and so they will not have this great diversity and abundance you see in the ocean. And then last, what part of the ocean has this lowest species diversity and abundance? That would be the open ocean, aka the area below the surface and above the sea floor. Why do we care about these aquatic systems? Well, there are two main reasons. First, it has economical value as well as ecological value. So, talking about economics, our aquatic systems serve as a means of food, so we gather a lot of the food sources we have from there. Recreation, travel corridors to take this food as well as other products up and downstream. Hydroelectric power, as well as employment. Looking at the ecological side, our aquatic systems provide climate moderation, carbon dioxide absorption, waste treatment and dilution, nutrient cycling, and groundwater recharge. There are 4 things that we are currently doing to threaten the health of aquatic environments. These include overfishing, habitat destruction, pollution, and global warming. What are things that you, as well as others, can do to reduce their impact on aquatic environments? Well, I'm going to list a few. First is to not eat aquatic organisms. This is not something that's viable for everyone, but it is a solution that could reduce our impact. If you decide that you do need to eat aquatic organisms, buy only Marine Stewardship Council certified seafood. This is making sure that the seafood is obtained using sustainable resources. Make your local supermarket and restaurants aware of the MSC certification, or give them a list of best choices so that they are making the decision on their own to switch to something like this. Educating others. This is not something that you can just do by yourself. It's something that everyone can do. So the more people you make aware of it, the bigger or lower our impact will be on the environment. Next is to not build on or fill in wetlands, because that's destroying these nurseries that help build our fisheries back up once we've depleted them. And also just consuming less in general. This is going to reduce the impact we make in waste, as well as pollution, as well as the need for organisms in our aquatic ecosystems.